Hi, everyone. I'm Wes Rades, the Executive Director of Bay Nature. Welcome to today's Bay Nature Talk with Walt Koenig about California oaks and factors affecting acorn production. Bay Nature connects people in the San Francisco Bay Area with local nature through our quarterly print magazine, weekly email newsletter, social media channels, and website. We're a nonprofit, independent media organization devoted to quality environmental journalism. Here's our latest winter issue, and our next spring issue will be on newsstands in March. We get roughly 50% of our income from donations and really appreciate everyone who's contributed $20 to support today's talk. We invite you after the event to subscribe and donate at baynature.org. Before we get started, a bit of housekeeping this afternoon. If you have any technical difficulties, please know that this webinar is being recorded and a link will be sent to you after the event. If you have any questions during today's talk, enter them in the Q&A box below you, and we'll answer as many of those questions as possible after the main presentation. Thank you too to the David Brower Center for today's technical support. Bay Nature Talks are an opportunity to bring stories from our magazine to life and to connect more deeply with our natural world. If you're looking for more ways to get involved, join us for a future Bay Nature hike or to celebrate local environmental leaders at our local Hero Awards on March 26th in Berkeley. We'll include more information in our post-event follow-up. Now, it's my great pleasure to introduce today's speaker, Walt Koenig. Walt is Research Zoologist Emeritus at UC Berkeley and a visiting fellow at the Cornell Lab of Ornithology in Ithaca, New York. During his career, he conducted long-term research at Hastings Natural History Reservation, located in Upper Carmel Valley, where he still resides and continues to study the behavioral ecology of oaks and acorn woodpeckers. Today's talk builds on Walt's summer 2022 Bay Nature story entitled An Enduring Oak Mystery, Synchronized Acorn Booms, which has been read more than 20,000 times on baynature.org alone. During his talk, we'll learn more about the issues that affect the variation and synchrony of acorn production in the trees all around us as they begin to flower this spring. His presentation draws from data collected for the California Acorn Survey, covering more than 1,000 trees at 25 sites across California. Walt, it's great to see you. Welcome. Thank you for being here, and please take it away.
Thank you, Wes. It is a pleasure to be here and to get to tell you all about the wonders, some of the many wonders of California's fabulous oak woodlands. As Wes mentioned, I'm now retired, but I'm a research zoologist emeritus at UC Berkeley, go Bears, and spent a part of my career at the Lab of Ornithology in Ithaca, New York, which is a wonderful place, but as I always told everyone there, not California. In any case, let's go on, and if I can get this thing going, I'll show you a nice photo of what a nice California oak savanna will look like in just another month or two, with the beautiful lupins about to come out. California's oak woodlands are not only some of the most fabulously beautiful habitats anywhere in the world, but are also, for those of you who aren't aware of it, some of the most extensive old-growth forests left in North America. Here in California, they cover about 10 million acres, about 25% of the forest, 10% of the land cover, and form a nice kind of circle around the Central Valley, but then, of course, go up into the northern parts of the states and are found pretty much everywhere except at the high elevations and in the deserts. But what's really unfortunate is that despite being so important in such beautiful habitat, very little of it is protected. Only 4% of California's oak forests are under any sort of kind of protection whatsoever. As a result, they're subject to a lot of threats of various sorts, not the least of which are development, both human and agricultural through vineyardization, They're also subject to a lot of changes in land use and habitats, such as the conversion of the native California bunch grasses, which used to cover much of California's grasslands, into what are now the Mediterranean weeds, basically native annual grasses from the Mediterranean, which started almost 500 years ago when the Spanish first showed up in California and began bringing their cattle and their feed, and throughout their feed, which then took over much of California and now form those beautiful rolling golden hills that we are all used to. There's also the threat of fire. Fire, of course, is a natural part of the ecosystem here, but because of land use changes, now can be a lot more, can cause a lot more damage than they probably did back in the days of the Native Americans. There's also climate change, something I'll talk a little bit more about later on. But the threat to California's oaks, which I think is the most interesting for various reasons, is what I like to call the regeneration problem. Why is it that California's oak savannas are so open? It's easy to walk through them. They are beautiful, such as this shot of one here. It's to no small extent because there's so few saplings, there's so few baby oaks, and that has caused a lot of people to worry about the long-term prospects of several of California's oak species. Are they regenerating fast enough to replace the oaks that die out there? It's hard to tell, something that people have been interested in for at least 50 years now. And why I find it so interesting is that even after that 50 years, much of which has involved a lot of intensive study, we still really don't know the answer. And that makes, to me, a really interesting problem. Okay, but let's get back to what let's get to what I actually am going to be spending most of my time on. I don't actually study the conservation of oaks, even though I'm, of course, interested in it. What I have studied is acorn production patterns, something I got interested in because of the importance of acorns to acorn woodpeckers, which I'll also mention in a few minutes. Acorns have been important to people for hundreds of years. These are more recent. These are just from TikTok videos that I got offline a few days ago, showing some people knocking down acorns off of trees to feed their pigs. Nowadays, I don't know that people still go around knocking down the acorns with sticks very often, but acorns are still a really important food resource in some parts of the world for livestock, certainly in Spain and Portugal, in some of the Mediterranean regions. It's something which leads to some very important food resources in the form of the pigs that get fed these acorns. More recently here in California, acorns were a really important food resource for the Native Americans. It's been estimated that over half the diet of some of the tribes of California Native Americans was made up of acorns. And for those of you who have ever tried to eat an acorn off of a tree, and if you haven't, I recommend doing so. It's an enlightening experience. You will not cease to be amazed at how much effort it must have taken to collect all those acorns, to store them, which they did in these special structures known as granaries, protecting them against all the animals that would have liked to steal those acorns, and then process them, leach out the tannins, the bitterness, in order to make them into an edible product. This is something that must have taken an immense amount of time and energy, and is, of course, why there are these grinding rocks throughout California in these foothill regions where Native Americans were once very common. Acorns are still, and always have, of course, been very important to our various friends of the forest, the squirrels and the jays and the deer that eat acorns and are dependent on them to no small extent. They've been shown to be extremely important to the entire ecosystem functioning. This is work not done here, it actually done in upstate New York, but not by me. But it's really important work that's shown that the acorn crop has important effects on deer and mice populations. The mice in particular then go ahead and have effects on ground nesting bird populations because they eat the eggs of ground nesting birds, so they have a depressing effect on their populations. They also eat gypsy moths and gypsy moth larvae. So there's, of course, a very important defoliator in eastern forests. The positive effects they have are on the ticks that live on the deer and the mice. The ticks then harbor Lyme disease. And so when there's a really large acorn crop, when it's a massed year, this affects the incidence and the danger of Lyme disease in these eastern deciduous forests. Lyme disease, of course, is also here in California. This sort of relationship has not been shown here, but is likely to have an effect here as well. It also has an effect on a lot of other ecosystem processes, one which some of you will probably be familiar with. This doesn't have to do with variation in acorn production, but in variation in another set of species in the conifers of boreal forests, the pines and the spruces and so on. They also tend to have variable seed production from one year to the next. And when they produce a bad year of seeds, this often prompts many boreal seed-eating birds to migrate and erupt and then be found in areas far south of their normal wintering range. This includes things like siskins, crossbills, and redpolls, which can be found in the Bay Area and even further south in years when the crop is particularly bad for some of these boreal trees. Closer to home, and I mean that literally because if I look out my window here, I can see a tree which acorn woodpeckers use frequently. The acorn crop has a really important effect on acorn woodpeckers, something that I have studied for decades, actually. It's why I'm here. They store acorns, of course, by the thousands in these granaries, storage trees, such as shown here. The acorn crop also has strong effects on their populations and geographical ecology. At a large scale, it affects their distributional ecology. So here is a plot of the number of oak species. So the oak species diversity of sites and the density of acorn woodpeckers. These are data from Christmas bird counts on the West Coast here. There are two really interesting things here. The lesser interesting one is that as you get more species of oaks, you get more acorn woodpeckers. The one that has always been of particular interest to me is that it turns out that the distributional limit of acorn woodpeckers is not set by the distributional limit of oaks, okay, where there are any oaks whatsoever, but rather by where there are at least two species of oaks. Why is that? Well, to make a long story short, it appears to be due to the fact that when you have more than one species of oaks, the acorn crop of one can offset, a bad acorn crop of one can offset, or rather a good acorn crop of one can offset a bad acorn crop of another, something that I will talk about more in a few minutes. But what may be of more relevance to many of you This is why, in case you ever wondered, there are no acorn woodpeckers in Oakland or no acorn woodpeckers on the Berkeley campus. And that's because those areas are right at the coast where there's only one species of native oak, coast live oak, and really there are just no acorn woodpeckers there. There are very few, but not enough to actually make a sustainable population. On the other hand, you go over the hill to Orinda and Lafayette, or down on the peninsula, down around the Stanford campus or the hills back there, and you suddenly get several species of oaks, and simultaneously acorn woodpeckers become very common. On a more limited scale, the acorn crop affects the reproductive success of acorn woodpecker populations. When it's a very good acorn crop, they have a lot of successful nests. So this is the acorn crop in the fall and the acorn woodpecker reproductive success the next spring. They tend to do very well following a good acorn crop, whereas following a bad acorn crop, they do relatively poorly. And one thing I'll also mention is that, interestingly enough, when it's a really good acorn crop, acorn woodpeckers are one of the few species here in California that will sometimes even breed successfully in the fall, having nests that start in September or even early October and fledge young as late as early November. As I say, something that is just not very common here, even in beautiful California. All right, well, enough about acorn woodpeckers, as much as I'd like to spend the next couple hours talking about them. We'll go back to acorns and the acorn crop, and let's focus here at Hastings Natural History Reservation, which is as Wes mentioned, is where I've studied both acorns and acorn woodpeckers since I was, well, a lot younger than I am today. Hastings is one of about 40 natural reserve system units. The UC Natural Reserve System, these are sites all around the state, reserves that are run for classes for education and research. They're each run by the various campuses, usually the UC campus that's closest to them. Hastings is unusual because it was founded back in the 30s when there were only two campuses of the University of California. And as a result, Hastings is still run by UC Berkeley, the Museum of Vertebrate Zoology, rather than the campus that is closest, which is, of course, UC Santa Cruz. Okay, so let's go there. We're going to start here at about 60,000 feet or so. Here's Monterey Bay, the Monterey Peninsula, Carmel Bay, and we're going to go up Carmel Valley here about 26 miles. And there we are at the lovely Hastings Natural History Reservation, which I just have to mention, I first came to Hastings as a graduate student in 1973 and thought it was so wonderful being there that I never wanted to leave. And incredibly enough, got lucky enough so that I pretty much managed to do that. I still live, well, literally as the crow flies, about 2 miles away from the reserve. And what we're going to talk about then is variation in acorn productivity. Now, acorns are really interesting. They vary along a whole series of axes, but we're only going to really talk about two of them just because I don't want to keep you here all night. And we'll start with annual variation because that's, of course, the one that everybody is pretty much interested in because it's so obvious that the acorn crop varies greatly from one year to the next. Why is that and how is it and what's going on? First of all, how do we actually measure this? It's a good question. There are a lot of different ways you can go about this, but for various reasons, not the least of which is that I got interested in doing this on a large scale such that using traps just wasn't feasible anymore. So what we do is that two of us go out we kind of make a party of this. We go out every fall in September and go to marked trees that we have tagged. So we go to the same trees every year, and using binoculars, we each count as many acorns as we can in a short period of time, really a short period of time, 15 seconds each. And that we use as essentially an index of what the acorn crop is for each individual tree. We then average those values across all the trees of a particular species at a site, and that gives us a value for the mean acorn crop of that species for that site for that year. All right, so we've been doing that now for quite some time. We started back in 1980, as a matter of fact, but I'll get to that in a minute. The species that I'm going to be talking the most about is the valley oak. The valley oak is an iconic species here in California. I'm sure you're all familiar with it because literally they're fabulous, fabulous organisms. Couple things you should know about them besides the fact that they have this interesting distribution, also shown by a couple other species, which is that they're essentially ring species, what's known as a ring species. They're found in the coast ranges of California, and then all the way down the foothills of the Sierras, and then back around here, the Tehachapis and Tejon Ranch back up to the Coast Range. They're wind pollinated, as are all true oak species. So they're not dependent on insects. The pollen is just out there floating around, as you probably are aware. They're also obligate outcrossers. So for an individual tree like this one, although it produces both male and female flowers, the male flowers, of course, are catkins. The female flowers, you may never have seen a female flower of an oak. I hadn't until not that long ago, but they're little tiny things on the branches, and they cannot be pollinated by the pollen produced by the same tree. They have to be pollinated by other pollen from other valley oaks that's being blown in by the wind. All right, so all oaks, all true oaks are wind pollinated and obligate outcrossers. One thing about valley oaks is that they also mature acorns in 1 year. So the flowers that are going to be produced here in another month or so are going to produce acorns this fall in September. Not all oak species are like that. It's a really interesting difference that I'm not going to really have time to talk about, partly because we don't really know all that much about it. But there are also 2-year species of oaks. And for those, the flowers that are going to be produced this year don't end up maturing into an acorn until the fall of 2024. And that actually has some interesting implications to the community level acorn production, as one might say, that I'm not going to actually talk about, though I would if I had a few more hours. Okay, so let's actually get to some data. And I've already alluded to this phenomenon of masting behavior, but I'm going to get a little bit more scientific about it now. Mast is an Old English word for the seed of forest trees, but in a scientific forum such as this, I'm going to be using masting and mast to refer to this phenomenon of variable and synchronized seed production by a population of plants. Okay, keep that in your head because that's what we're going to be talking about, and I'm going to explain it here in a little more detail. Here are the data for valley oaks at Hastings over the last 40 years. The solid dark line is the mean acorn production of the trees, of the 80 or so trees that we do every year from 1 year to the next. And as you can see, it's highly variable. Some years they do really well, other years they do really badly, and sometimes it kind of goes back and forth like that. But it's also, and this is even more important in many ways, synchronized. So if these paler lines here are the acorn production of individual trees. And as you can see, in a good year, pretty much all the trees are producing a lot of acorns. In a bad year, hardly anybody produces any acorns. So masting, this is really important, is not an individual phenomenon. An individual tree does not mast. Masting occurs by virtue of the fact that a population of trees are all doing pretty much the same thing from one year to the next. Though I will also point out that if you come up here to, this is around 2015 or so, things have kind of fallen apart in the last few years. Something that I'll refer to later on, though I'll tell you now, we don't really know why or what's going on, but it of course makes the whole thing very interesting. And that's why here 40 years later, I'm still busy counting acorns pretty much every chance I get. Okay, so why are they doing this? How are they doing it? Let's get to the why first, and I'm not going to spend a lot of time on this, but I do want to spend a couple minutes. This is now asking the question at an evolutionary level. What is the adaptive advantage to trees, to a tree, to producing acorns, an acorn crop that's synchronized with the other trees around it, rather than, for instance, either not synchronizing acorn production or one of the reasons that almost everyone in the field agrees with is that it goes back to our friends of the forest. If the trees produce the same number of acorns every year, then presumably the squirrels and the jay populations would rise to the point where they might actually eat all every year because they have this predictable food resource. Whereas if it varies greatly, when it's a bad year, it'll cut down on those populations of jays and squirrels. They won't be able to reproduce very well. And the next year, there won't be as many of them, such that if the trees produce a lot of acorns, then many of them will survive to be able to reproduce and sprout and produce baby oaks. That's a phenomenon known as predator satiation. And as I mentioned, it's one of the major factors that presumably is making it selectively advantageous for trees such as oaks to mast. There's another factor which is also probably important and seems to be important in many cases, which is called pollination efficiency. The idea being that if all these trees put a lot of effort into producing flowers, catkins like these, and female flowers at the same time, a higher proportion of them will be fertilized. It'll be more efficient than if they don't do this synchronously or all produce kind of a lesser number in each year. So those are two of the potential adaptive advantages, the whys of why oaks mast and why other species such as these boreal trees that I mentioned earlier also are a well-known masting species as well. But what I've ended up studying a little bit more commonly is the phenomenon, if I could move this, excuse me a second. Is what are the proximate factors driving masting behavior? So how do they do it? I mean, how do they manage to synchronize their reproduction from one individual to the next? Okay, excuse me. Well, the way we look at this is that we look for correlations with the acorn crop, and with valley oaks, there are two of them that are particularly important, one of which is what they did the year before. So it turns out that if you look at what the trees did last year, if they had a poor acorn crop, or if they had a very good acorn crop, then they're likely to have a poor acorn crop this year, and vice versa. If they did very well last year, very poorly last year, I get that mixed up, they're likely to do much better this year. This implies that what's happening is that the trees are using up resources to produce all these acorns, and it takes them a couple of years at least to recoup all those resources to be able to have another good crop. The other factor, which is important, has to do with weather. In terms of valley oaks, this is the mean maximum April temperature. So conditions in the spring, when it's warm and dry, they tend to do very well. When it's cold and wet, they tend to do very poorly. And what this suggests, what's happening in April? Well, it's kind of the end of the pollen season, but those flowers are still getting fertilized. So between these two, what it suggests is that both resources and conditions during pollination and or fertilization are important drivers of what's happening, of what determines whether these trees are able to produce a lot of acorns or not. I want to delve in that in a little bit more detail. How do they what is it about weather that affects the fertilization? One of the things that it seems to be important has to do with bud burst, of flowering, which is something that probably all of you are aware is just about to happen out there here in California's oak woodlands. Okay, it turns out that in warm, dry years, when weather is good, what happens is that the trees tend to flower more synchronously. Okay, when they flower synchronously, all that pollen is there at about the same time. There's lots of it. If they flower asynchronously, like these two trees are doing here, then the pollen is spread out over a longer time period, and there isn't as much of it at any one time. Plus, the trees are flowering at different time periods, so there just isn't as much pollen for all the trees. When there's lots of pollen, turns out pollen is limited for these trees, so there's lots of pollen around when they flower synchronously. Pollination efficiency is presumably very good, and they're able to produce a very large acorn crop. Whereas you get the converse of low fertilization success and a small acorn crop when it's cold and wet in the spring. This is a phenomenon that we call phenological synchrony, and is one of the hypotheses for how weather may be directly affecting the trees in a way that they then translate into producing a variable acorn crop from one year to the next. You can also see this within a year. If you look at the trees that flower right in the middle of the season, that's right here. So these are the trees that are flowering when the most other trees are flowering. That's when presumably the most pollen is around. And in fact, those trees tend to have the largest acorn crop the next fall, whereas trees that exhibit bud burst flower either early in the season or late in the season when there's less pollen around tend to have smaller acorn crops. Okay, but before you get too excited, I just have to mention that I've just been talking about valley oaks. This may also be true for blue oaks as well, but it's not true for all of the species in California. So here's the relationship again between mean maximum April temperature and the acorn crop in valley oaks. But if we go to another common oak species that most of you are going to be familiar with, coast live oaks, if you plot the mean acorn crop versus the mean maximum April temperature, you basically get no relationship whatsoever. What coast live oak acorn crop correlates with is the prior year's rainfall. So not this year's, so not this winter's for this coming fall's acorn crop, but the rainfall that we had in the winter of 21-22 is what is going to correlate with whether we get a good or a poor acorn crop this fall. Just to remind you, we didn't have a lot of rainfall that winter. And so we're probably going to be down here in the relatively poor acorn crop range for coast live oaks. The point is that not all the species are affected by the same environmental factors. We don't really know why. We don't know what's going on with all these different species in many cases, but the fact is this is part of what then is going to be driving the variability between species as to whether they're going to have a good crop or not. All right, so let's go back to the ways that acorn crops vary. The second one I want to get into, I'm going to skip individual and community variability and just talk a little bit about geographic variation. And let's go back to the definition of masting behavior. You'll recall that this is the highly variable and synchronized seed production by a population of plants. But how large is that population? Are we talking about the trees in my yard, all the trees here in Carmel Valley, or what? And this gets to a phenomenon known as spatial synchrony, which I want to spend just a minute or two explaining so that you're all on board here. Spatial synchrony is the correlation between localities through time. So say we measure the acorn crop at 4 different localities over a 7-year period and then plot the values. If it looks something like this, it has very low spatial synchrony. If we know what the crop is in one site, it basically tells us nothing about what the crop is like in the other sites. They're all just cycling independently. However, if it looks more like this, and it could be even more extreme, if it's a good crop here, it's probably a pretty good crop at the other sites as well. If it's a bad crop, it's a pretty bad crop at the other sites as well. That's high spatial synchrony. So what they're doing at one site pretty much is the same thing as what they're doing at the other sites. Okay, and we get at this through, as Wes mentioned, the California Acorn Survey. We go to about 20 different sites, more like 25 really, around the state every year. It's sort of one of the foci of my retired life these days. It takes a couple of weeks for us to go around there, but it's a lot of fun. You get to see a lot of California, and it's such a big part of my life that it has its own newsletter, the California Acorn Report, which I put out every fall. The idea being that we again go to mark trees at all these sites and measure the acorn crop using our visual surveys in order to be able to figure out what's going on at this large geographic scale. So we're going to do that now very quickly, show you how this works. Let's take 2 sites that we count valley oaks at, Hastings and Jasper Ridge, which is, of course, Stanford's biological station behind campus. And here, if we do exactly what I just talked about, each one of these is the yearly annual acorn production at Hastings plotted against Jasper Ridge. And what you can see is that they're highly correlated. The correlation is very high, 0.81. These sites, by the way, are about 129 kilometers apart. Let's take 2 sites that are much farther apart, Libre Mountain in Los Angeles County and Tower House up in Shasta County. If we do the same thing for them and plot them, the correlation is lower, but there is still a pretty good correlation. These sites are 745 kilometers apart. Okay, we have 10 sites in all where we do valley oaks at the moment. And so we have 45 different pairwise correlations like this. What we're going to do now is we're going to plot the correlation coefficient versus the distance between these sites. And we're doing this for these 2. Here's Jasper Ridge and Hastings. Here's Tower House and Libre Mountain. And now we're going to magically add the 45 other pairwise correlations that we have for the other sites, all plotted against distance, correlation coefficient. And as you can see, the correlation coefficient declines with distance. This is perfectly normal. It's what you expect. But more interestingly, this pretty much covers the entire range of valley oaks and even trees that are 600-700 kilometers apart, at sites 600 or 700 kilometers apart, the acorn crops are still correlated with one another. So basically, when it's a good crop here at Hastings, it's basically more or less a good acorn crop throughout the entire range of valley oaks in California, covering thousands of kilometers, square kilometers. We're talking about millions of trees. In the case of blue oaks, which show a similar pattern, we're probably talking hundreds of millions of trees, all of which are kind of more or less doing the same thing from one year to the next. How do they do this? Well, I want to quickly talk about the possibility that trees are talking to each other. I'm sure all of you are aware of the talking trees phenomenon. This is a real thing. Trees do communicate through their roots, both through their roots and through the fungi that they're sort of sharing with one another. But this is an important phenomenon on a scale of meters, maybe tens of meters, maybe 100 meters, but certainly not the hundreds of kilometers and the millions of trees that we're talking about. What does seem to be driving it are environmental factors. So here's the graph I just showed you of spatial synchrony of the acorn crop. If we look at the spatial synchrony in temperature and rainfall throughout California, it's very high. It's much higher than that, in fact. So when it's a wet year here, it's a wet year pretty much everywhere else in California too. And this is what is apparently driving this synchrony over this amazingly large geographic distance. So spatial synchrony in acorn production, at least in terms for valley oaks, covers its entire geographic range. Spatial synchrony is primarily driven by environmental factors, something which is known as the Moran effect, after an Australian mathematical ecologist by the name of Patrick Moran, who studied Canadian lynx back in the 1950s. All right, well, I don't want to end without saying at least a couple words about climate change and how it may be affecting things here in California. I do have to mention that climate change here is a little more subtle than it is in many other parts of the world. Here at Hastings, which is all I really know anything about, there has been no long-term change in rainfall over the 80 or so years that we have data. If you plot rainfall, which as you know is highly variable from one year to the next, it just hasn't changed over the years. The same is true for mean maximum temperature. It is not hotter. The hottest days are not hotter than they used to be 60, 70, 80 years ago. What has changed, and this is a fairly common pattern, is the mean minimum temperatures. So it's not hotter than it used to be, but it's not as cold as it used to be at night, presumably be having to do with coastal influence, something like that. In any case, the mean minima temperatures have gone up by about a degree over the past 80 years. What sort of an effect has that had on the acorn crop, on masting behavior? Well, that's a good question, one that maybe I'll actually answer in the next 50 years. But to show you, it hasn't had an effect on the mean acorn productivity, though there's a big caveat to that, which is that the way we actually measure the acorn crop with our visual surveys, it probably does not do a very good job of getting at what we would want to know in order to test that. But what may have been changing is the variability and then the synchrony, as I mentioned earlier on in the talk. If you plot the synchrony of the trees at our population of these valley oaks, it kind of winds around, but then over the last 20 or so years, it's really gone downhill. What's going on there? Well, as I say, another 20 or 30 years, maybe I'll actually figure it out. Okay, well, that's really about all I was going to tell you about, all I have time to say about these wonderful oak woodlands. I just want to encourage you all to appreciate them. I can tell you that I get up every day and look out my front window and just, this literally is my front yard, just look upon the the Santa Lucia's here mountains, which just are fabulous. I consider myself incredibly lucky to have managed to stay in this part of the world basically my entire career. And I'm sure you feel the same because it's just a wonderful place to live. So thank you. That's really it. I do want to thank Museum of Vertebrate Zoology, again, Go Bears, and all the other people who have helped this project over the years. Back to you, Wes.
Wonderful. Well, thanks so much. I learned so much from your presentation. You've given us so much to appreciate while we're out among these trees this coming year. We have time to take some audience questions that have been flowing in while you're speaking, and we'll give you a moment to catch your breath. I'll remind everyone in the audience that you can submit a question yourself using the Q&A function that you should see at the bottom of your screen. We'll take a moment to collect and collate the questions. Walt, we've got some folks who are interested in coming out and counting acorns with you. The first question comes from Amber. It's a two-parter. She's interested to know, can volunteers sign up to help with the annual Acorn Survey? And how can interested folks sign up to receive your annual Acorn report?
Okay, well, I have long thought that it would be great to start a citizen science project, where people will go out and actually count acorns all across the state, if not the world. We have not actually really gotten such a thing going as yet. As I say, at this point, it's kind of something that I do to keep myself off the streets and out of trouble every fall. But keep an eye out. It is going to happen one of these days where it's going to be organized, where that could be a possibility. In terms of the actual Acorn report, I have to warn you that it kind of masquerades or doubles as my family newsletter every year. It has relatively little to do with acorns per se. It's really my annual excursion into creative writing. But if you really want a copy of it, you will have to email me your mailing address because my goal is to have one of the last newsletters in the world that I actually print every fall and put in. There are these things, I think I may have one here. They're called envelopes. I think I have one here somewhere. And you put these things called, don't tell me, stamps. That's what it is. And there's this whole organization that delivers it to people. Anyway, I still do that, though it does end up online. Usually my website may be dying, but if you Google Walt Koenig Cornell or Walt Koenig Acorn Survey, you will probably, with luck, you will find a site which has the Acorn Survey, California Acorn Report on it, and you can download it. Probably the easier way to go about it, and you can see what you're getting into.
Terrific. It sounds like you're going to be in touch. The next question comes from Gwen. She's interested to know, how long does a valley oak take, and a live coast oak for that matter too, before it can produce an acorn crop?
Well, it doesn't take them very long. There are a lot of interesting things about young oaks. It's not really what I have studied, but if a tree is in a good site and it's protected so that it survives, probably within 10 or 12 years, it can start producing acorns. There's some pretty small trees out there that will produce, at least start producing a crop. So it certainly takes them a few years, but it doesn't take them 20 or 30 years to be able to get to a stage where they can produce a good acorn crop.
So this question comes or results from the variability in acorn production year to year. And so it's a question about what, going all the way back to the native Californians and then animals today that rely on acorns as their food source. How did the native Californians, how do animals today survive during off years when acorn production is effectively zero? And how do they make it between the booms and the busts?
Okay, that's a good question. The Native Americans, as far as I know, they would move around and they would take advantage of the different species. One thing I will bring this up, I did mention that there are these 1 year and 2 year species of oaks. They are both, at least to some extent, the acorn crop is related to conditions when they're pollinating and fertilizing. And as a result, the 1 year species are completely uncorrelated in terms of their acorn production with the 2 year species. So and here in California, you don't have to go very far to get from, down where we are here at we're at about 1,800 feet here, where it's primarily blue oaks and coast live oaks and valley oaks. All you got to do is go up into the hills a few miles away, and you get to black oaks and canyon live oaks, both of which are 2 year species. So if you can't find acorns down here, you just move a few miles up there, and with luck, you can find some up there. And that's pretty much what I think a lot of the animals do too. Certainly, the only one I really know about is the acorn woodpecker. It's not very common. There's enough oak species diversity here that you don't get a complete failure of all species very often. But the times we have had very bad crops of all of them, a lot of the birds disappeared and then came back the next spring, presumably not going all that far away, presumably just going up here in the higher Santa Lucias, where there are, again, these black oaks, canyon live oaks, and also tan bark oaks, which are not a true oak, but also are a 2 year species, produce acorns, and presumably managed to make it through the winter.
This is wonderful. The questions coming in now are now starting to build upon one another. I feel like we're in a group setting together.
There are a lot of good questions about
the questions right now are about there's a lot of interest in smoothing the variability that you've observed. And so the question from Ronald here is whether researchers have done experiments by irrigating oaks in gardens or in other controlled environments to see whether it's possible to smooth the variability or to see how that correlates to acorn production.
Yeah, there's a lot to be said about that. We've been very interested in trying to do experiments kind of like that in oaks, but you're talking about trees that are not easy to deal with on a reasonable time scale. So I won't really go into that. What I will mention is that there are a fair number of agricultural crops that are what are called they're they produce biannually. Okay, so I think apples are one. You get a good apple crop 1 year, a bad crop the next year, and it literally does that from 1 year to the next. And there are a series of other agricultural crops that are like that. And I can assure you, agriculturalists have been out there for decades trying to figure out how to get rid of that. And they have not succeeded. So it's really hard. I'm not sure it's impossible. Certainly trying to modify the synchrony, which is what we've been really interested in doing, and which there have been, a small number of experimental studies trying to do that in masting species, has the potential to really give us a lot of insight into what's going on in masting. But they're hard experiments to do. There aren't very many of them. And it's something which I'm sure people are going to be working on in the future.
Excellent. So we have time for two last questions, and I've got the two here. One calls all the way back to the beginning of your presentation, and then the other one is is more forward-looking. Beth asks, are there any fertility projects planned to spur oak regeneration and address the shortage of young oaks that you mentioned at the beginning of your talk?
Well, there's certainly there's been a lot of work on how you can sort of help these oaks, things like valley oaks, which very well maybe have this problem. What you have to do to sort of get them to regenerate, how to protect them, from all the animals and so on. So there are certainly a lot of people who are working at this in places where there are reserves, where people are planting them and so on. But as I think I said, really one of the interesting things about it is that you don't have to live in California oak woodlands very long to kind of realize that regeneration is something that happens really slowly here. And I am not convinced that is a new phenomenon. I think it's been slow for hundreds of years, to a large extent because it's just so dry here compared to, I have a slide. I just have to throw this in. One of the other places that we counted acorns for many years was in Minnesota. There are oak savannas there in the Midwest, which are a threatened ecosystem. In Minnesota, if you don't burn those oak savannas, within 5 or 10 years, you can't walk through them because there are so many baby oak trees. And here, that just doesn't happen. So it's unclear whether, things are on a different time scale than we're used to dealing with. So it's really hard to tell whether it's even a real problem or not. I'll kind of end it at that. Hopefully that didn't totally evade your question.
Thank you. The last question we've got today is asked on behalf of the citizen scientists and the nature enthusiasts who are in the audience today. I'm sure there are many of them. The question is, what can we do as citizen scientists and nature enthusiasts while we're out in these lands among these trees this year to participate in the phenomenon that you've described? What should we be observing? What can we be on the lookout for? What can we do, if anything, to increase the number of successful oak seedlings?
Well, it's a good question. I think, of course, a lot of oak conservation here in California has to do with preserving areas that are, wild lands. As I mentioned, there's a very small proportion of oak woodlands that are protected. All those great national parks are up there in the boreal forest, basically, up in the mountains. And, there's some great state parks, but, we could use more of them. It's a habitat that is threatened in many ways. So in terms of helping, being aware of the problem and helping to do what you can to help preserve oak woodlands, oaks in California is probably the most important thing. Certainly just to see the phenomenon. Next time, when you go out in the fall, take a look around and see how synchronous or asynchronous the acorn crop is, how it varies from one species to the next, because they don't all do the same thing at the same time. And which is an interesting phenomenon when it comes to why they're doing this, and the predator satiation hypothesis that I pointed out earlier. I could go on. That's not much of an answer, I'm afraid. But really, it's a fabulous ecosystem. And the more of us that appreciate it and let the world know how important they are, I think the more likely they are to survive in the future.
Terrific. That's a great note to end on this afternoon. And on that note, we'll have to conclude. Walt, I want to thank you for sharing your expertise this afternoon with all of us in the Bay Nature community. We really appreciate it. And we look forward to observing the trees and the grounds all around us this year as we're out there ourselves. Everyone, I want to thank you all for being here today. That concludes our Bay Nature Talk. We want to thank Walt. We want to thank everyone who donated, everyone who attended. I want to thank the David Brower Center for all of their technical support. In the coming days, you'll get an email from us with a link to the recording for you to share. And in case there's anything you'd like to see again from Walt's presentation this afternoon, thank you, and we'll look forward to seeing you next time. Have a great evening.
Thank you.